real quickly, I wanted to introduce some concepts of text mining and then try and show, provided that there's still time to do it, how we were able to leverage that in a project to get additional predictive power over just using the structured data.
Well, that is, I would be very eager to see that.
Okay, very good. Then let me go ahead and open. Can you see what looks like a spreadsheet right now on your screen?
Now I can.
Okay. What this is, I'm going to be walking through this today in Statistica software, and as Don says quite often, the tool doesn't necessarily matter. It's just, this is the tool that was used for this project. I have worked for Statistica, and I have worked for SAS, and I know there are some very specific text analytics products out there, but I would have to say of the more popular, more commonly used ones, I actually like SPSS Modeler's text analytics the best, but that's just my personal opinion.
Mark, can I interrupt real quick? SPSS, I think there is student licenses available, and I think they're like $200 or less, and it's normally like $20,000 or some, so students, if you like this stuff, that's something maybe you can even do at a later date, show the text miner from that, because I'd like to see that as well. How much does this, before, I don't mean to be cutting into your time, but just how much does Statistica, how much does this cost, and do they have a student license?
Two very different questions. If you're going to actually get mining functionality, you'd probably be looking at starting at about 15 grand. But a student license, I'm trying to remember if it's $25 or $50 for 6 months.
Wow!
But it's very affordable.
Would they have the text mining stuff in there, or do I have to get that separate?
What I'm going to be working with today actually is the free 30-day. I had to install it on a new machine very quickly, so I just went in and took the free 30-day license from the website, and as you can see, it's got data mining in it, it's got text mining, it's got all sorts of descriptive statistics, industrial statistics, so there's a lot in there for that. I think you can get, without the data mining, I think the student license is free, but obviously once you get past like 401 or 402, you need a little bit more than that. But it's still pretty cheap.
Okay. Well, I didn't mean to interrupt. So I'd love to see this. This looks fascinating already.
Okay. Very quickly then, what this data that you're looking at is something that we use the web crawling feature to pull from websites. I'm not going to talk about that today. Obviously, you can populate unstructured data from anything, but we pulled from a carreview.com. It's sort of a chat board where people go in and say, what type of car do I have? How much did it cost me? What type of rating do I give it? Strengths, weaknesses, and a summary. So very simply, we're only going to be looking at 4 different cars: a Lexus, a BMW, Mercedes-Benz, and because the results didn't come out that favorably, I've camouflaged. The 4th one is Car ZZ. I could have just as easily called it Don Wedding's old Dodge Dart or something like that, but you're not going to get the real name of the vehicle here. So what we want to do is we want to come in and obviously do, I've already got that open, and we want to get ready to do some text mining. So I'm going to analyze this column here called summary. And I'm going to say we're going to do it in English, but most products will have multiple languages, and obviously there's a lot of context that has to go on, not just the specific language, but how the language is used. So it's very important when you find one of these that it has multiple languages. And I've already told it I'm only going to pick the top 300 terms or return information about the top 300 terms in here. Now, very quickly, what I want to say is we're going to come in, and when you do any type of text analytics, it's typically very important to have a dictionary. One of the things I like about SPSS is they have these resource templates that are context specific. So for instance, if I say, oh, I'm trying to do customer sentiment, it already, and I'm trying to do it in English, it already has a bunch of rules predefined. But pretty much whatever software you use, you're probably going to have to come in and do a fair amount of modification to this dictionary. The one thing that you always want to use is something called stop words or a stop list. And essentially what that says is, depending on the language here, this happens to be English, there are words that typically don't add any value from an analytic perspective. Things like pronouns, I, me, mine, she, he, it, things like that. So it says if you find these words, just ignore them. And I've come down, because this is about vehicle data, I just said, oh, if you see something that says car, I imagine there's going to be car a lot of times in this data. Ignore that. I could customize this as much as I want. And in real life, you would have to. Then what you want to do is say, I want to do some synonyms. So for instance, you might see auto. You tell, and it should be able to figure out based on the root of a word, but I'm usually pretty specific. So auto, I say, is the same as if you find automobile, if you find car. You see one of the, in the data, they say M-Benz. So I say M-Benz is the same as Mercedes or Mercedes-Benz or Benz or MB, etc. And then one other thing that can be very important is phrases. Sorry. And what phrases means is if you see these two words contiguously treated as a single term, so things like peanut space butter. If you were doing shelf life or market basket analysis for a supermarket, you'd want it to say, no, they didn't buy peanuts and they bought butter. They bought peanut butter. So here I'm just saying things, gas and tank, it should be treated as one term or one phrase, sun, roof, because we're talking about cars. I know I'm going through this very quickly. I'll come back to it in a minute and talk about how you figure some of that out. And then there's another option called inclusion words, just the opposite of stop words. You might say, no, I only want to look for terms or phrases X, Y, and Z. And if you have an inclusion list, it will only look for those. So if I want to say, if Don wanted to look through teacher evaluations and only wanted to find the ones that were for Don Wedding, I would use an inclusion word, Don Wedding, and it would throw out everything else. So what we do now is we've defined some very basic parameters. Yes. And here what I'm going to do is create an initial index of the terms, the phrases that are in what we call the corpus or the body here. And it, by default, shows it to you alphabetically, but it gives you a count for the number of times that term or that phrase appeared and the number of different documents or different files it appears in. If you're doing a raw, binary would just be 0 or 1. And I'll talk about inverse document in a minute. The reason this is important is, let's say you're doing customer sentiment and you see that all of a sudden the word terrible or the phrase terrible service shows up 100 times. Well, you're pretty concerned. But now if you find it's only in one file, it might be one person was very upset and said over and over and over again, terrible service, terrible service, terrible service, which is a very different context from saying it showed up 100 times in a total of 100 different files. That means there's 100 people that think you have terrible service, not one person who's really upset. Here we say the corpus included 638 documents. It's showing me the first 300, but there's about 4,000 unique terms in there. And what I typically do is I do a descending sort here to see which are the terms that are showing up, which are the terms that are showing up most frequently and also for the highest number of files. And I'll explain that in a minute when I talk about a project. But when we look at this, it's common to use what's called inverse document frequency rather than just a raw count or a binary count. And what an inverse document frequency is trying to do is say, let me do some weighting based on the number of times this term appears and the number of documents it appears in. And then let me also figure out if it appears a real lot of times, if it's in every document, in every file, maybe it's something that should be on the stop list, so it actually starts saying, well, let me start adding some weighting to terms that show up very infrequently. And so there's an algorithm to do that. Then what we do is we can say, let's look at the frequency matrix. And what we see here now is down the rows here, this is just each individual document, and here are the terms, or the stem of the term that it found. And we can see, for instance, the word also. Well, that probably should have been pulled out in our stop list, but it's got different weightings in different documents. So there's different frequencies of this term appearing in document 17 versus document 14. Okay, let's go back. And then what we want to do is how you're going to take this now. We saw there were 4,000 terms, but even with 300 terms, it can get very unwieldy. So you want to say, how do we get this down to the least amount of, well, I was going to say information, the least amount of terms, I'll use that word right now, that provide the most amount of information. And that's via something known as singular value decomposition, which is very similar to the concept of principal component analysis. It says, what are some dimensions or almost bags of words that are combined together that add the most meaning to the document or to what the contents of the document. So if I perform singular value decomposition, we started with 300 words. It says, I'm actually going to break that down into 15 concepts. Okay, well, what does that look like? Let's do a Scree Plot. And I think by this time, people should be familiar with this, but basically you're looking for where there are these cliffs in the data to determine how many concepts you want to use. But for instance, we see concept 1 and concept 2 give us something like explain 25% of the total document, and maybe if we go up, you could say there's a cliff there maybe, or a cliff here. That might get us to 40%. Just to make it simple, I'm going to say use 10 concepts. And then what you want to do is you want to look at word coefficients. This is how you determine, now that we've taken this and broken it down into 10 concepts, what's really in the concepts. And I could use something like, say, well, let me sort concept 1. And it tells me concept 1 is about I drive, I like, I get a BMW. That all sounds really good. Oops, there might be a problem here. So maybe I like to drive my BMW, but I've got a problem. But we don't know that yet for sure. That's just giving us, these are the terms that contributed the most to concept 1. And we could do a similar thing for concept 2, etc. And here we replace problem, fix transmission, car is easy, or Don Wedding's old Dodge Dart, whatever it might be. So this is one simple way to decipher the terms in each concept. And then what I want to do is look at the importance of the terms overall through the whole corpus here that we're analyzing. And I apologize, I know I'm going very quickly. But apparently, downwetting's old dodgy dart is the most important term. Transmission is number 2, BMW, problem, Lexus. Okay, we still don't know who has the problem and if it's a transmission problem, but we're starting to break some things down here. So what we can do is say, I want to do a quick scatter plot of this, and I'm going to do a very simple scatter plot, and I'm just going to say, show me concept 1 by concept 2. And what we can do now is the scatter plot, what you're trying to do is say, what are things that are not sort of all grouped together, things that seem to be unique to one concept or another. And a little mouse impaired here. Lasso, yep. Let me take all these, if you will, outliers here. And let me take perhaps these down here. And now if we do this, what we're going to see is concept 2 seems to be very positive. I like the look and feel and drive and the sportiness of the BMW, whereas concept 1 is telling me car ZZ, transmission problem, maybe I spent a lot of time at the dealer. So that gives us an idea of how we can start getting a feel for what these different concepts are and what they're telling us. In the interest of time, I was going to show a quick cluster analysis, but basically when I did a cluster analysis, I'll just tell you, things like BMW and like and drive and very positive sentiments about BMW were all in a single cluster, and another cluster had replace, problem, transmission, service, car ZZ, all in another cluster. So we're starting to really hone in on that there seems to be transmission problems or quality problems with car ZZ. Now, let me just jump very quickly to a couple of PowerPoints here just to show how we use this at on a customer engagement. What the engagement was a major airline that was trying to determine causes for delays and cancellations of flights because they say anytime the plane's not in the air, it's costing us money. They throw a lot of data at us. There's so much data, and like any really large company, they had everything there. You know, they had SAS, they had SPSS, they had people using Excel, they had people using Minitab, but there was very little interaction, and so things were very manual, and people weren't really doing anything with any of the text data, but what you would get is information about airplanes and how many flight hours they had and how old they were, and then what flight number was delayed and what airport was it at, and which plane did that unique aircraft ID did that apply to or correlate with. And then there was a file with unstructured data. And basically it's typically the pilot or someone in the cockpit that writes up a note that says, oh, we had problem XYZ. For example, we had no power. And then you have another bit in there where the person who services it ultimately says, well, this is what I did to resolve the problem. And they had never looked at any of that before, and they were trying to do preventive maintenance to try and predict failures before they happened so they could reduce delays and cancellations. So what we did, I just want to remind people about crisp DM and why it was very important here. It's very important to know your business and know your data. And we went in there and said, we don't really know your business and know your data. And they said, well, we can't write up a data dictionary for you. Come to us when you have questions. Well, you can't come to them every 5 minutes. So what we found is, for instance, as we went through, oh my goodness, look at this high count for these terms, REP and MEC. Then we went back and looked at the data, and REP just meant the problem was reported by so-and-so. and MEC was the mechanic ID, or the mechanic who wrote the note. So all of a sudden it was like, oh, we thought we had something very meaningful, but we didn't. When synonyms,
this is Don. You're kind of running over. Are you almost done? I mean, this is fascinating.
Okay, let me just go to the end then. So the way we found these phrases is we did a link analysis, and we found that bleed and air seem to have strong linkage between them, and cargo, door. So we went to the folks, and they said, yes, bleed air is something with our hydraulic system, and cargo door is something, etc. So it's part of the iterative process. That's how we built out the dictionary. A lot of hunting on our own, and then coming back with some questions, and then prediction accuracy, and I'm going to wrap it up right here, Don. When we first did this to predict failures with just the structured data for this APU, the model predicted correctly, it had 91% accuracy of APU failure, of the APU, state of the APU, but it never predicted any failure. Fortunately, aircraft component failure is very rare, but what turns out is you have a model that's 91% accurate and 100% useless, because it never predicted any failures. So what we did is we started looking at some of our concepts, and we found that 7 of our concepts were in the top 10, I guess, or top 15 most important predictors. We identified what they were, and for instance, hydraulic pump failure. And we were able to come back and take those concepts and add them to the model on the first pass, and all of a sudden we went from no predicted failures to 72 predicted failures with almost 63% accuracy. And then, again, it is iterative. We kept improving that. But that was with the exact same data, just structuring the concepts and that adding those concepts in with the structured data, the impact it had on the predictive capability of when the APU might fail. And then as we refined it up, it was actually something they were comfortable with to start predicting, okay, under these conditions, or, here are the business rules of when we want to do our predictive maintenance. And I will end it there. And I apologize for going long.
Well, that's okay. I mean, it was fascinating, and text analytics is another area that is way underutilized, and I think it's probably because there's just not a lot of really user-friendly tools out there, but this is great stuff. And believe it or not, for the students on the phone, if you can get good at text analytics, you can really supersize your models. You can really put them on steroids just by pulling out some text analytics from it. So I would love to be able to, if you wouldn't mind donating your PowerPoints to this, I'll post them for the students to look at. But if it's confidential company stuff, don't. But
yeah, unfortunately, you see in the bottom right now. This, of course, I guess you're recording this, but and that's okay. I didn't really show any of the data behind it, but I guess because the slide has Dell Confidential on it, I probably can't just hand it over to you, unfortunately. I'll check, and if so, I'll send them to you, Don.
Okay, great. And I'll try to. The other thing is, if you can even scrub out and like just the stuff on the Statica or whatever, that would be great as well. Just whatever you can. But anyway, let me pull you off now. I didn't mean to run over on, but this was really good stuff. But
thanks, Don.
So okay, who wants to be next on this list here?
Do I need to stop sharing, I guess?
Yes, you do. I'm going to make you not a presenter anymore, Mark. How about
that? Okay, then it won't matter. Okay.
Okay. Let's see. I'm going to do an eeny, meeny, miny, mo. Hey, Diane, did you ever get back?
I think so. It crashed a couple of times while I was offline, but it looks like it ran finally.
Oh, really? Okay. Let me.
Like, crashed twice, and I rebooted. So.
Center. Okay. You know what? Diana, that's you. You're sharing. I'm gonna let Diane go next, guys. Ladies first, and besides, she won the eeny, meeny, miny last time.
So is that working?
I can see your desktop, Diane. So I'll try to be a little bit more strict on the what's the word I want, the timekeeping. I kind of got into the text finding.
This should be pretty short. I can't see anything though.
I can see your screen. I can see predict for. I can see your mouse moving around.
Oh, okay. Okay. It's weird doing it as a presenter, so forgive me. I'm a little bit. It's weird not seeing the other screen. I can't see the question screen or anything.
Don't worry. Somebody will see it.
Okay, so you can see my PowerPoint.
I don't see the PowerPoint. I just see at this point predict 410.
Here. Let me move it to my other monitor. Is it there now?
Yep, I see it. Perfect.
Okay, great. Okay. So basically, a couple weeks ago at work, we discovered that we could use the lag function, and at the same time, we do a lot of report writing and data analysis, just basically for anyone in our company. I work at a medical company, and that's what we do. And we've had a lot of requests for the question usually being something like, how long does this process take? How long does this process take? They're trying to figure out how many people they need, how to optimize processes. So we discovered that we could use the lag function because there's lots of different databases that don't really talk to each other very well, and some of them are quite old. And in a few of them, we needed to see data from a previous row to understand where something had moved and determine how much time it was in that step. And that's what the lag function does. It basically compares values from the current row to values in a previous row. So that's what I just said. And in the process that I'm going to show, I just made up some data, and we have data with an item ID, the date it moved into the next step in a process, and then using lag, you can see the previous move date. And once you have that, you can do whatever calculations you need. So I made up some data for class. It basically just shows part number 1 comes in. This happens to be sort of simulated returned part data that goes through our service process. So we'll go through process 1, process 2, and this is the date that it moved. So here's the code for the lag function. It's right here. So it's a nice, tiny little bit of code.
I'm having a hard time reading that. But you shared the slides with me, right? I can post those.
Yeah, it did turn out kind of small. I can see that it's really tiny.
But that's okay. I mean, the fact that it's there and we have the slides, that we can get at it.
Yeah, I can make it a little bigger like that. There we go.
That works.
So that's it right there, just that one line of code basically. And what it does is when you run it, it takes this date and puts it down here, and then you can see the difference between the previous date and the date that it moved, so 2 days basically. And this is the one that state diff is doing the math on that. And then the other part of what you can do with it, I can make this a little bigger for a sec. It's going to run over the other one, but move it over. You can do a sum on it using the lag function again. So here's the lag down here, and let me shrink that. And basically, make this a little bit bigger. So I have those date differences, the time that was in the phase, and then you can start doing a running total by item number 1, and then you can do sort of a total of how long it was in the entire process. So it's really easy to use and very useful. And then the last thing we did for this particular customer at work was we just pivoted the data so that they could get an idea of how long everything was in every process. And they can start tracking, like, if they had something like this where it was 12 days, like what was the problem there? And that's it.
And this is a perfect show and tell because you did just enough. We got the idea. We got some example here, and this isn't ripping on Mark here. Mark, yours was great too, but I'm just saying this is what I'm looking to do for others in the future. This was great because the only thing I want to know is, can I do this with older SQL, or do I have to use later SQL?
I think it was, at least in our version, we needed 2012 to do it.
So it'll probably be something that requires, will be going forward, but maybe older SQL, maybe not so much.
And I don't think older SQL does pivot either, as far as I know.
Wow. Does anybody have any questions for Diane? I didn't mean to be hogging the questions.
Yeah, Diane, can you hear me?
Yep. Yeah.
This is Tom. Order obviously is important. I mean, you have to sort the database in a specific order too, or index on a particular item. I saw you had there something an order by. You had some additional parameters. Can you do like where clauses, or can you skip through, or does it just the previous line that it compares it to?
It just compares it to the previous line.
Okay.
I'm going back to the lag here.
But you do partition it and order it by.
Yeah, you partition it by ID. So I'm partitioning it by ID and ordering it by the move date.
Okay.
But I think there are other things
line.
you can do, yeah, to get the previous one. But somebody else told me you could go back more than one, but I haven't figured that out yet.
You mean like instead of the previous line, like 2 lines back or something?
Yeah. So
it's like Flash Black of time series.
Yeah, so we were all Googling it. So I think there's a lot more that can be done with this. You can also do lead, which is the same, except obviously going forward.
That's interesting.
Well, I'm very, very happy about this. Let's see if there's anybody else typing, got any questions. If not, we'll move on to the next people.
Okay, thanks.
Diane, thanks so much.
Don, can you make me also present? I didn't install yet.
Okay, sure. This is Ram?
Yeah, sorry as well.
Okay. So Ram, I'm making you a presenter as well. And Diane, I'm taking it away from you.
Yep. Thanks. That was interesting to try that, Don.
Well, hey, you know what? I hope we're going to do this more of these throughout the quarter. So other students, you see the variety of different stuff. SQL, the text mining stuff. Some people go long, some people go short. It's just throwing ideas out and you just absorb the stuff on what works for you or what people find interesting. I probably go the rest of my life and write like 10 lines of SQL, but the fact that I know it's out there is important to me, that I can do a lead and a lag. So I love seeing this type of stuff. Okay, who wants to go next? I'm going to see who's next. I'm going to go eeny, meeny, miny, mo, and do Tom Prichard. How about that? Tom, you want to make you the presenter
Super.
there?
Yep.
Okay, Tom, you're up. Tom is another one of my former students. You were in 411 with me, weren't you, Tom?
I think it was 410.
Whoa, okay. And interesting is Mark, our first talker today, worked with me at SAS. So he and I were in the same division. He worked for Emilio, and I worked for Anand, right there, Marco? Or Mark Vaglio, Lauren? So this is interesting. This is like a reunion for me. I got Mark, I got Diane, and I got Tom. Okay, what do you got for us today, Tom? Oh! Yes, this is what I wanted to see. Thomas, you're on mute, though. That's the problem.
How's that?
Okay, I can hear you.
Okay now? You can hear me?
Bayesian Inference. Oh, this is going to be great.
Yeah. Let me just tell you what happened. I sat in a marketing class. Well, first of all, I sat through statistics, and then I sat through your class, and we all get wrapped around the p-value. And everything is based upon a null hypothesis and whether we get a 0.05 plus or minus. And I've always asked myself, because I was a psych minor in college, and it always bothered me, like, what if I get a point, what if it's 0.94, not quite the 0.05? What if I don't get that? Does it mean I blew it, or does it mean So it's always bothered me about this magic number that we had to hit. And we also know what we've learned in statistics that if you increase the data set large enough, you're going to find yourself being significant one way or the other. You can get significance if you really want to. And so the whole idea of the p-value always kind of bothered me just a little bit. And what happened in my marketing class is a guy named Professor Lynn Bacon turned us on to Bayesian. I read a paper, I think I posted it in my references, about the myth of the p-value and how people make mistakes with it along the way. And so that started me on this Bayesian trek. And like I say, I'm in the process of reading. I'm surrounding myself by books. I'm reading it. I'm playing with it. For me, it's not as useful. I don't think I can give you much today to use in something for this quarter. But if I can just wet your whistle to the idea that there's more than just the traditional, what we call frequent statistics, and you take a look at something like this, or don't run away from Bayesian. There's actually two camps in statistics. There's this frequentists and Bayesians, and for years the Bayesians have been getting the back seat of the road. They've been, in fact, they get left off the bus most of the time. They're kind of ostracized. But in the last 10 years, especially in 20 years since computational power has increased, Bayesian analysis has really come to the forefront, and it's offering some solutions to everything that we're doing. The reason I like Bayesian, because everything we do in life is subjective. We live in a life of probabilities. There is a 70% chance of rain today, and it rained all day. So obviously they were right. And we always want to question, what does 70% chance really mean? We talk about there's a 6% chance of developing heart disease based upon your conditions, or a person has a 400 batting average. What does that mean? 8% of the drivers hit a deer in that particular area. What does that mean? And so how do we handle probability? And the fact is that everything we do, when I look at a number, I really want to know how certain you are of that number. And so, it gets down to, in this book by Krusky, in doing Bayesian data analysis, he simply says it's the reallocation of credibility across your possibilities. Or it's looking at your various options, your various parameters, and you begin to assign credibility to the various parameters or possibilities. Here's the problem with the p-value. I'm not going to read this to you. The idea is that it's arbitrary. The 0.05 or 0.01, we just pick that number. In psychology, I was taught that if 0.01 doesn't work, then you go to 0.05. And I've seen research papers that you can't, or 0.1, because they couldn't get significance until they relaxed the parameters. So obviously, the numbers don't mean anything. They just fudge them around. People, in statistics, we spend a lot of time talking about p-value, what it really means and doesn't mean. But people still think that it tells you it's a chance the null hypothesis is true, but it's not what it's saying. It's basically the idea of if you compare it to a randomness, what is its probability that the actual outcome was actually random, something of that effect. And then here it says, in many studies, medical trials especially, this is where it becomes very interesting. Null hypothesis one, no change, in other words, but it says here, you can substantially increase the sample size and you will find a mean that is approximately close, and it will be significantly different. Therefore, hey, our drug's good to go, let's go to market with it, when really all they did was mess with the numbers. There's a psychological journal that recently has said we're no longer accepting p-value as your base for proving that your thing works or that your theory is correct. The steps is very simple in Bayesian. Identify your data, define your descriptive model, which is something we do in any kind of method. But then what I like about Bayesian is you start with a prior distribution. You start with your prior assumptions. In Bayesian statistics, it's okay to guess. It's okay to start with preconceived notions and then let the data drive those notions either to greater certainty or to literally destroy them or reverse them in some cases. There's no danger in assuming the wrong direction because the data will push it back, especially like in a Markov chain or something like that. So you let the data then change it. And what also Bayesian gives us is after you've come up with your model, additional data can tweak that model. Whereas in statistics, you start all over again. You take the data and you have to run it again and you come up with new numbers. But in Bayesian, you can take your priors, run it against your data, come up with your posterior predictions, which is what your new numbers are, and then you go back and apply more data as it comes available, and your model changes. So it's like life. We are constantly taking in new information and we're adjusting our assumptions or our understanding of it. So Bayesian is a viable approach to solving things. And what I want to show you is a demonstration of that. One of the books I read, it was what got me down this path is the area that I'm really excited about is risk analysis. And not the one I took in predictive analytics. I took risk thinking, well, maybe I can get a little bit of information about risk. But it was all about finance and how you can't predict the stock market or how you could try to predict the stock market. But I wasn't concerned about finance. I'm more about operational risk. I'm more concerned about when we make a change in our infrastructure, our IT environment, what's the probability that it's going to fail? What's the probability we're going to have a disaster? Of risk, and that's what insurance companies do, and they do use our Bayesian analysis. This is a program that's called a Gina Risk by a company out of Europe. They wrote a book. The book is a little version, but it's on risk analysis and the entire approach. And this is an interesting model. It basically, what they've done is they have gone after how can we graphically present Bayesian concepts. And then examples, and I'm just going to share one of the examples. But these become nodes in your Bayesian analysis. One thing about Bayesian is there's no looping. I think, Don, you did neural networks, and I believe they have feedback loop networks. You can circle all around and come right back again and go into a nice little loop. One thing about Bayesian, there's no loops, but it does do backwards and forwards. So as the example here is, it's the idea of a person comes into a doctor, there's something wrong with them, and they want to say, okay, and it walks you through a scenario here, such as the patient complains of shortness of breath. So, right here he's got shortness of breath. So we're going to turn this into a yes. And I'm just going to run the model here, each step. And notice how the parameters change. Suddenly, even though the arrow is going in this direction, it actually fed things back. But what we're saying here now is his chance of tuberculosis is still very low, because people don't come down with tuberculosis very often. It's low. He probably has bronchitis. But then this additional data comes in. The guy says, well, yeah, but now he says, we have the patient is not a smoker. So I say, okay, he's not a smoker. So what's that going to do to my numbers? And this is what a doctor goes through when you walk into the clinic. I'm not a smoker, so now what's going to happen is specifically watch these three lines right here: tuberculosis, cancer, and bronchitis. Now, our bronchitis has gone down, lung cancer's gone, dropped down some, still no tuberculosis. But then the guy says, hey, have you been to Asia lately? Because Asia is heavy on tuberculosis. The guy walks into tuberculosis and says, yep, I've been to Asia. Oh, the person has been, yep. And now watch what happens. Okay, still no tuberculosis. But then the doctor goes ahead and prescribes an X-ray. And he takes a look at the X-ray, and the X-ray comes positive. And suddenly he's now had tuberculosis. And the parameters change. He doesn't have lung cancer. Bronchitis is significantly, and now we go focus on our prescription as being, let's treat the person or take a look at the person for tuberculosis. So Bayesian offers a decision mechanism that can assist doctors and anybody who has to look at risks and multi-factors to determine what, and these are, you can see what they're based on ratios, how many people are coming back from Asia, what's the prevalence of TB in Asia, and how many of those can come back with tuberculosis. So they actually feed into these various trees. This is a binomial, primarily it's just all yeses and nos, but you can do this based upon normal curve, Poisson distributions, you name the distribution model, you can put them into here and pick different types of priors, if you will, or the likelihood, what kind of curve is it going to follow. So that's about, without going into detail about everything else that I looked at, it's an exciting concept, it's an exciting field, and I've been bugging the university for the last 6 months trying to get them to teach a Bayesian course in the analytics program. He got a hold of Lynn Bacon, and he asked him if he would do it. He said he would do it as a special topics. He said he's not sure if he's ready to do it as a seminar yet, but he says, interesting thought. He says the university kind of is not really jumping on it right now. I'll tell you one reason: they're probably all frequenters, darn frequenters. And the second reason, he says, they think the concept's too difficult for the students at Northwestern. So we need to prove them wrong. So I want to encourage you, take in your free time as a university graduate or as a graduate student, but do some poking around with Bayesian. I think you're going to be excited about what's out there because life is unpredictable, but everything is driven by probabilities. And the more we understand the probabilities, the more we can understand the outcomes, whether it's elections, whether it's health. I walked into my doctor recently and had a physical. And he said, well, your cholesterol is better than it was last time. It's still not great. And I said, well, how big concern should I have? And he pulled out his iPhone, and he popped in there my cholesterol numbers. He popped in my weight, my height, my age, and a couple other pieces of data he had right there in front of him. And the iPhone popped up and said I have a 12% chance of a heart attack in the next 10 years. And I go, dang, that's a Bayesian device. It took all these parameters based upon known heuristics and came up with a probability. I can live with those odds. And I think 12.5% is pretty good. So it's creeping in. There's an iPhone app I saw the other day for stroke. I put in my numbers, and I come up with a 1.3% chance of a stroke. So, check it out. And most of these are based on Bayesian mathematics behind the scenes. So I'll get a little excited about the idea. Go ahead.
I'm excited about this. Can I interject something? Is that
sure.
In my role at SAS, I do go from company to company a lot, okay? And I'm starting to hear more and more, especially in marketing departments. You're always going to have your classical statistics. I mean, that's not going anywhere. You're always going to have your machine learning, which I think is actually kind of a cousin to this. But Bayesian is starting to get mentioned more and more and more. And I think if you really want to get on the cutting edge of something, now I'm not going to say that this Bayesian stuff is going to just replace everything else, but it's going to find a home, and it's going to be, if you know how to do this stuff, I think it could be very valuable to your career. So I just wanted to second what Thomas was mentioning in this is it's worth learning this stuff, and look, what you showed with the tuberculosis example was fascinating. What software was it that you were using, and can students get it cheap or free, or is there anything?
A Gina Risk. Let's see if I got the website here. I do. It's a company called Gina. You can Google it and look for GinaRisk.com. They're out of Europe. They have two versions. Well, they got three. They have the commercial version too. Anybody can order the light version. And that basically is right here, the light version here. And you can download it. It's a crippled version. I'm not even sure how crippled it is because I got the other one. I bought the book. So I got the Gina Risk Lite version for free. I just demoed there. One of the things that was missing, it's missing some of the distributions. It doesn't have a Poisson distribution, I think, is one of them. They basically have pre-built-in data distributions that you can use as your pre-model. Their commercial version, I thought was extremely expensive. I wrote to them, I says, what's it cost? And they says, it's like $25,000. And I go, students, give me a student discount. And they go, $2,500. And I go, I can get SAS for $99. Come on, guys. But I said, sorry. So, aside from this nice graphical picture model, you basically going, but in code, you got JAGs, you got bugs, which is in the R camps, you got PyMCMC, which is Monte Carlo Markov chain, you got open bugs. Those are some of the modules you can add to in Python and in R and run it. So I don't know what SAS does with Bayesian because I got into Bayesian after I got away from SAS a little bit. So I haven't looked at that. I'll let Don speak to that.
They have something, but I don't know much about it, and I couldn't intelligently talk to about that, but I know they got some stuff in it. But this is cool, this GUI interface that I saw here. Can you also send copies of your slides if you'd be kind enough,
Sure.
or whatever you want to get, because
Yep.
this is good stuff. And again, this is something that I would highly recommend along with the text mining and the SQL stuff. Actually, everything tonight has been very valuable, but I just want to say this is something that you don't hear a lot about, but I really highly recommend learning this stuff. So, and I know very little about the topic, so if I'm going to sneak in on Lynn Bacon's class if he teaches it.
Well, he does one module, one 3-week section on Monte Carlo Markov chains, which twisted our brains. I mean, nightmares about that for months afterwards. It was difficult, but I got so excited by what its potential, and especially that it takes on the p-value and says, you know, there's a better way of doing things. Because when the result of a Bayesian is, I can tell you how sure I am of that number, as opposed to a null hypothesis saying, well, you can accept or throw out the null hypothesis. But how sure are you of that null, or that hypothesis? I mean, it does not tell you how sure you are.
William Kreckler is asking you to repeat the R modules again.
Oh, JAGS, J-A-D-S, called STAN. I just downloaded it and looked at it a couple of days ago, but I haven't done anything with it, S-T-A-N. Bugs, there's open bugs, there's Win bugs. Win bugs is a Windows version, open bugs is a little bit tricky, but that's a big one. It's a Gibbs sampler. The GS stands for Gibbs sampling, which is how it goes about pulling out from the data set.
Actually, if you know, can you just put, when you send out the slides, would you be kind enough
I'll
to
add
just
it.
either put it in the text or?
Well, I'll add a slide here. I didn't put for the 2 languages what some of the packages are you can look at.
That would be wonderful. This was great, and I'm personally really excited about this. So thank you very much for doing this, Thomas.
You bet. Thank you.
Okay, I'm going to make you a participant now. So we've got Ram, Troy, and David. Is there anybody else that wants to present tonight? Because I'll just, make it so you can start installing stuff. Okay, well, in the meantime, I'm going to say, Ram, you're next. So, but if anybody else, just type in the chat window and I'll make you a presenter so you can start installing things. And my lovely wife called me from San Diego. She's visiting her relatives out there, so I'm going to hope you guys go, well, gosh, Spark, this is great. I got to see this too. Told my wife I'd call her after this, but I'm geeking out on this stuff. This is great. This is another topic. Pay close attention, people. I'm starting to see Spark all the time, too.
Can I get started?
You sure can. I'm already interested.
All right. So, hi, everybody. I'm Ram, and then I'm doing 411 course right now with Don. And then and thanks to Shivaraman and many other contributors on open source, from which I stole all these presentations and code, so thanks for them. All right, so we have been hearing a lot about big data and how big data can really help you processing, how you can distribute to multiple clusters and get a lot of things done. But the only problem and the challenge in the R community was that R could not integrate well into the big data space, and then the problem with R was R used to run all of those processes on a single thread, single machine, so it was really, really resource intensive and you never had an opportunity to distribute. However, having said that, R has wonderful capabilities, and what really happened was the problem boils down to this. Before we had a large set of data, and the way R used to handle it was you need to process outside somewhere and then make it into a smaller set that can be fed into R, where the learning models will receive that. And then you build the model, you train the model, and then you test the model and do all those things. So all the heavy lifting, heavy processing was done outside, but the problem really with that was, by the time you do all the process, you are really, the data is no longer useful, or it's stale data that you're working with. So SparkR came up with a great idea of combining this all together and integrating it R, so that way you get the best of both. I'll show you one. So if you look at Spark has has this high speed. They say even it's 200 times faster than Hadoop, so it's much more faster than Hadoop. It has integration with Python, it has integration with Scala, it has everything actually. and then it is scalable, it is flexible. On the other hand, you have R, which has great statistics packages. It has the beautiful data frames, so flexible that you can work with, and then you have all those visualization packages. So what SparkR does is combine these two into one single world. And then what SparkR uses is, SparkR uses this resilient distribution data set RDD, which is kind of splitting the big data set across multiple clusters that can be operated in parallel. So you get the beauty of parallelism using SparkR. And then what they have done in SparkR is the ability for you to use SQL-like functions on top of the data set. And also you can use Spark's data frames. I mean, you can use R data frames and do everything that you can do in R, but you would not even realize that you are working on Spark, but internally it is using the Spark's engine. Spark is actually distributing all the data and doing the heavy lifting for you behind the scenes. Now, the architecture-wise, if you see right now, it's the same. You have the RStudio or R console on your local machine. You fire an R program, and then the Sparks pick it up, and then Sparks kind of converts it using the R JVM, and then it converts to Java Sparks context, and then it distributes to all other nodes that is available. And you don't need to worry about it. Sparks does it for you, but this is the architecture. Now, what Sparks also has is a beautiful machine learning algorithm. We have been building on heavy machine learning algorithms. So what happens here is all the heavy lifting, all the heavy computations that you cannot normally do right now with on the entire full data set, you can do it using SparkR. And then they made it so simple that just like how you use R, you see model and GLM, and then you have the response, and then you have the predictors and data frame and all those things. So you don't even know that you're using SparkR, but behind the scenes, it's running all. Now, what you need to do is you need to install Sparks. I have installed Sparks on my local machine, and then I'm running a SparkR local component. And for the benefit of everyone out here, I have built a small documentation on the steps that you need to follow. All the steps, I don't want to go over this right now. Once you follow the steps, then you should be able to install Sparks on your Windows. So I'm going to make an assumption that you guys have installed Sparks, and then you have Sparks running. So let me go with a quick demo.
Ram, can I ask a question before you get, is this free? Is this going to cost me money? Can I download it, or do I have to pay a huge license?
No, everything is free. You go here. I have all the links here that I will share with you. So you can go to the Apache Spark. It's a Sparks project. You download the Spark. It is available for Windows. It's available for Linux. I'm not sure about Mac, but Linux definitely would support. So I guess even for Mac users, you should be able to do that. And this is the ML library that is available here, and you can see all the types of clustering, classifications, and everything that is available right now, which can be run on multiple nodes, probably in 100 different locations, 100 different servers. You don't need to worry. It does all the heavy computation and gives you all the results.
What are the nodes? Are they Spark nodes?
No, those are those are all the clusters, nodes on the clusters. So you have 10 machines running, and then you have a big data application which is which is running on these 10 machines, and then you install Sparks on top of it and use R. Then internally SparkR calls this all the nodes and manages all the data that is being split between various nodes, and then run all the computation, and finally it gets you all the results. So the distribution is what So it's a machine, but it's a collection of multiple machines. So I will go to the demo.
Is it like Hadoop, or is it? I'm sorry.
Yes. It's like an Hadoop, but you can also run it on a standalone. I mean, even Hadoop you can do it. You can have a single instance of Hadoop. Right. But the whole purpose of it is to distribute and do the heavy computation on multiple systems. And they're also giving you machine learning, so it will be super fast. So you don't need to run a day or two for all the models to run, and you realize, oh, this is a mistake here, this is a mistake there. Oh, it stopped.
No, we would have done that.
Let me share again. I don't know what happened.
So it's not like a Hadoop backend. Is it Linux? Are the Spark clusters running on Linux?
Yeah, Spark cluster
Okay.
is running on Linux. Yeah. That's
Okay.
right. But you have the Windows end, so you can still have your SparkR local installed on your Windows, and then connect to the, from the Windows you can connect to the Linux, or, oh, it doesn't like me. It just stops sharing my screen.
Might be working. So is it an R package, or is it a completely different front end, or is it RStudio that has an R, like a Sparks library?
Yeah,
This is
here, I will go over the, I'll go over the Sparks
Okay,
library.
super.
So what I'm doing right now is, first you need to set the environment variable in RStudio. So I run this. You will tell R where the libraries are. It's a basic thing. You have to do it all the time. And then I'm going to load the SparkR library. So once I do SparkR, here it is. So the first step is, it is giving you a SQL-like abstraction. So you need to run this function here, which will actually make, which will actually create a SparkR instance for you. Here, you see here, if I can tell, I can run it on local or I can run it on remote, and then I can give number of threads that I can run, which you can never do in R. So
I think
then I'm going to
frozen. Is it? Are you moving your cursor at all?
Yeah. Can you see right now?
It's frozen for me. I'm just seeing your RStudio and you're pointing to the printer.
Yeah, that's what I'm seeing too.
Something is happening. I'll just stop sharing. And sorry about that.
I could let me make him a participant and then a presenter again and see if we can fix that. Huh. Okay, now I'm going to make you the presenter again, Ram.
Yeah. Okay. Now can you see my screen?
Yes, we can see your screen, and we can see your mouse moving as well.
All right. So this is the first one which I was talking about. So I'm going to run it on my local. I'm going to create a Sparks instance, and then I'm going to create a SQL instance, SQL context. So what it does is it will let you run all the features that you can do on a data frame if you're comfortable using SQL-like programming also. So I'm going to read our famous Moneyball data set. I believe it's famous by now. And then I'm going to create, if you see here, I'm going to create a local data frame. I'm sorry, I'm going to create a Sparks data frame here. It is just the same. You can say create data frame. You would pass on the SQL context, this one, and then you will say which data frame you want to. So I'm basically converting a regular data frame into a Sparks data frame. It's running right now. Yeah, it's done. And then what I'm doing is, if you want to use SQL-like function, I'm going to convert this into a table. So registered temp table will actually make this data frame into a table-like. So I think most of you are familiar using tables. So what it does is, now I'm going to say SQL, and then I'm going to pass SQL context, and you see here, I am going to treat this data frame like a SQL and do all the SQL functions. I'm going to say select star where target wins is greater than 100, and then run this one here, and then it's going to return. Now, this is a Sparks data frame. So just like how you do R, regular R, if you do run here, you're going to see the schema, not the data. So you need to use head. When you use head, you'll be seeing you will see all the results here. So all the ones which based on the condition, a new data set is created, and then what else? If you want to load the data frame into RStudio, again, if you want to convert this data frame into regular data frame and then use it for some other model elsewhere, you can simply say collect, and then after all the heavy computation that was done on the Sparks, you get the result, and then you will convert to your regular data frame and then use in conjunction with a any available R package. Now this will work. If I say Moneyball, you should be able to see the result here. Now, what you also see is that you can use the existing data frame, and then you can run this GLM and all those. You see create data frame, and then you have SQL context, and then I pass on this. Right now I can't do it because I have 1.4.1, but this runs on 1.5.1. I didn't find time to actually change this, but this is a simple one. I create a data, I run this model here, and then this, just like anything, you have response, and then you have the predictors, and then you have the data frame, and then you say class is equal to, so on. So this will create and fit the model, and then this is the model variable. What you can also do is, unlike the painful way that we did in SAS, I don't know, maybe there's a better way of doing. I need to go and look at all the variables and then use the loadings like 0.5 into team batting and create all those formulas. I don't need to do it here. I can simply say predict, and then I can use this new test data, and it will predict and give me the response. And then you can display this, and then finally, if you are done, you can stop Sparks using SparkR. If you want more information, this is the documentation. There is so much R and then SparkR related, all the functions that is available here. This is the documentation, and then you can go to sparks.apache.org and you get all the information. So I took some examples from here, and that's how you can integrate big data, Sparks, and R in one single interface.
Wow, you got me worried, Ram, that this is going to put me out of work soon.
Ram, questions for you. So the Spark is open source. It's just something you install on top of Linux boxes for each one of your nodes?
Yes.
No
I mean, right now there is an option to install Hadoop on Windows too. So I'm not really sure if there's a workaround to install Spark, but right now the documentation, it supports Linux boxes,
okay.
and yeah, so it runs on Linux right now. But on the front end, you can have anything. It's just cluster management and all the big data stuff that's run on Linux. I'm not sure if anybody's doing it on Windows right now.
And yet your sources for, if I wanted to do one of these and set it up, what would it take to be like, could I do it all on one machine, even though if I didn't need multiple clusters?
Yes, but you will not see the, then it will be as good as running an R, because R, the feature of R is it can only run on one thread. Now, some of the other things that you can do, which I didn't cover here, is if you go to this documentation. Oh, my screen is frozen again. Yeah, here, if you see right now in one of the examples, they have brought in a JSON file. You see here, Spark understands this JSON. So one of the examples which Mark was talking about was pulling data using crawling. I believe the data would have come in JSON format, or if you are doing Twitter analytics and pulling data from Twitter, you get JSON files, and every data that you see outside is mostly in JSON. So you can see here, you can simply read it like a data frame, and then you can do all the operations that you can do on a data frame, and Spark does it for you.
Wow, thanks,
Ram, this is Dave. If somebody wanted to play with this and they didn't have access to Hadoop, would the best place be somewhere like just AWS and set up some servers?
Yes, it has. There is a YouTube video on connecting to AWS and multiple cluster management and all those features. So if you don't have Hadoop, this document here in Spark gives you what all you can connect. Like you can connect to HDFS, Yarn, and there's many more. Yeah, you can do that. Yeah, here you see. It runs on Amazon EC2. It runs on standalone deploy mode, which I did right now. And then it runs on Apache, Yarn, and many more, I guess, in the future.
Hey Ram, obviously you got some slides and stuff. Can you send us everything you have, and we'll post all this for everybody else?
Yes, I'll post this R. I will post the steps first to install on your local machine, and then this PowerPoint. I'll do that.
Wonderful. This was great. I know so little about this topic, but I hear so much about it that I know it's going to be huge, and I would recommend students,
Yes.
to explore this further.
And people who are comfortable using Python can use PySpark. And then if you look at the examples here, they have a lot of examples that you can combine with Python. So they have given you even examples on how to run any of these ones.
So this is the R and Python solution to big data.
Yeah, that's right. That's PySpark.
Wow.
Yeah.
That's amazing.
Yep, I'm telling you, I love show and tell. I learned so much from you students when you do this stuff, because half these things you guys talk about I don't even know about. I mean, I don't even know they exist. So this is always great for me too. Ram, I'm going to cut you off unless there's anything else, because I got Dave Hurst and Troy Arias.
Sure, thank you.
But I'm really, really happy about this. Thank you so much.
Sure, welcome, anytime.
Okay, Dave or Troy, who wants to go next? Or do I do the scientific eeny, meeny, miny, mo thing?
I can go. Mine relates to RStudio, so maybe that's a logical follow-on.
Okay, well, Dave
Probably
Hurst,
okay
you're
with
it
that.
then. Okay, go get him, Dave.
Okay, let me see which one this comes up on here. Okay.
Dave Hurst, you're another one of my former students as well, aren't you?
No, I'm not. I was. So what's showing up here on is a? Are you guys seeing? Is it? I can't. What's showing up? Is it an email or an R, or is it RStudio?
It's RStudio.
RStudio.
Okay. All right. Thanks. Yeah, there's no indicator. I see what I am was having trouble with. Okay. Yeah, no, I was not a student of yours, although one of your students may have referenced me last quarter. I was helping him out, Joshua Meeks.
Yeah, I know him.
That may be where you got my name.
Okay.
Anyway, what I wanted to present on was our Markdown, and so it's actually pretty simple. Some of you might be really familiar with it, but others that have used RStudio and haven't used it, I think will find this really useful, and I use it almost daily. So again, it's only going to be useful if you're an RStudio fan. But I'm going to start off, and everyone can see the screen and everything is all good?
Yes, I see it at least.
Okay. So let me just kind of start off, so everyone knows if you go to a new file, you get our script. But if you haven't played with this option, our Markdown, it's really pretty cool. So I'm going to start off. I'll just do the simplest thing. I think RStudio does a great job of giving me starter templates. So here's just something. If I come in and do nothing but hit knit HTML, let's give it a name. So it'll run the R code, and it will create a document for me that sews in, comments that we've got, data that you spit out, and plots all in one. I actually kind of think this is what all assignments ought to be handed in on. But just to play around with this.
Too cool. I love this.
Yeah, it's really good. So I just ran a PDF there. So this is also obviously very helpful because you can just email this off, and it's got it all in there. If you need to make a change, somebody says, oh, you have a parameter wrong, you just rerun it. Your whole document's there, no cutting and pasting. One thing I will warn you about on the PDF, though, is that the PDF is a little less robust. So if you do use PDF, just constantly every few hours, you may want to just regenerate a PDF just to make sure it all looks good. I tend to I work with, I just stay in the HTML. But I was just going to go through, sorry. I just was going to go through a few of the options just to give you some of the ideas of what you can do here. So let's go back to this data set, use a more interesting data set, but maybe related. So empty cars, and I'll just kind of run it here. So those are well, I'm sure a lot of you are familiar with empty cars. It's used in a lot of examples. We could come in here and change our plot. So go here. Viz, and then empty cars. I'll just create a simple plot here. So let's plot the weight of the car on the x-axis and the miles per gallon on the y-axis, and make that a scatter plot. So this isn't part of the demo. This is just standard. But you got to have some color, right? Fill is equal to, so we'll color it by the cylinders. I think there's, if I go down here, the cylinders, there's 4, 6, and 8 cylinders. So let me run that first here within RStudio just to make sure the plot's good, and then we'll come back and regenerate the document. Okay, so there's the document now. The next step might be, well, okay, so I've got my text, I've got my summary, but I want to throw in the data. So you could create another chunk. And so everything that's in this R code gets executed. And I like to use this library X table. And so here you could take empty cars and pipe it to X table. And pipe that to just a regular print statement. And so if I run, again, I'm going to run that here locally. So it spits out all this HTML here, and just real quickly, I'll show you what happens here. This is probably not what you expect. So now you get all this HTML in here, but what I want to do now is there's some parameters you can set here. So let's say results as is. So just tell it basically not to use the Markdown and just run or plot the HTML straight. And so now you've got your document here. So just a few more. So here's an HTML table. So this you can take. I'm just up here in this YAML, and this is all really well documented. So don't worry about trying to understand if you're not familiar with it. But so if you're all familiar with cascading style sheets, you could go. I've got one in here called Impact CSS, and let me just make sure that's the right name. Yeah. And so knit that again, and then you can reuse that guy. If you find a style of table that you like, you can reuse it over and over again on your documents. So a few more things you might want to add if you're doing a report. You could add a table of contents. In this case, I'd need to kind of put some context to that. So let's say this is an intro section. Here are my plots. And here's my data. And we'll see what that looks like. Okay, so now you've got your document here set in the 3 nice little sections that you can put up. So if I've got a little more time, I could show one more cool thing.
Sure, I like one more cool thing, but do it a fast one more cool thing.
All right, it's a fast one more cool thing. If you want to do something beyond just the documents, you can turn this into a presentation and run that. And then your document turns into a slideshow.
Oh, that is too cool.
And it's got some nice little controls too. So you can put speaker notes in this as well. It's just stuff you wouldn't think about being in our package. But
can you export this as a PowerPoint?
You can't export it as a PowerPoint. What you can, so it's just an HTML document is all it is. So I just mail it around. It takes people a little bit getting used to have an HTML instead of a PowerPoint, but it's just a file. So you just take what did I call it? Show and tell.
Yeah.
It's this thing right here. So you just throw that in an email, and they'll see the exact same thing. So I think if you had, so there's this open in browser. This is what they'll get if you give it to them in an email. So they can do that too. They don't need our. What's that?
I said, can you send all this to us? But you might need to zip it all up because there's so many files. But can you send this to me also? And I'll
sure. You want the file I just created, or
everything? Throw it all together. That way, the students, when they watch the video, will get the whole thing. Give whatever you think will be useful to the students.
Okay. So yeah, so that's kind of the point. Is that everything is only really two things. It's the Markdown document right here that I've been working with, the same document, and the HTML file that I put out. And those are the only two things that there are.
Okay, that's fine. I mean but in like
I
think RStudio. Do you download RStudio? It's not in CRAN. You have to get it from a different website, don't you?
That's right. Yeah.
So you might want to put that link in your email or whatever.
Okay. Sure. Yeah, I'll send you those things.
This is really useful stuff. I really like this.
Good. I'm glad it was helpful.
Does anybody have any questions for Dave, or I'm going to fast forward on over to Troy, but I do think this is fascinating. You're getting
I'll answer the question that didn't come.
No, you got Mark Vaglio is typing something.
Okay. I can't read what he's typing. I don't know where to look.
Didn't know about the presentation capability. Oh, he's saying thanks for the sharing. I didn't know this was possible. I mean, this is really good.
Yeah, it's. I'd also play around with Shiny as well. It's also all up in that very first thing where you can do a presentation, a document, or because you can also do things. You can make some interactive documents too.
Oh my gosh, what's this called? That you just. This is called what?
That's called Shiny. So that was just, so again, it's just down in the R Markdown. When you create a new Markdown, you have a choice between presentation, a document, a presentation, and Shiny, which is that interactive document.
Oh my gosh, that is too cool. Oh, okay. I'm gonna have to monkey around with this one too. Dave, I'm going to cut you short just because we're running out of time, but this was fascinating.
I'm done.
Really excited. So
yeah, I'm done. Great.
Thank you so much. Troy Arias, you are last but certainly not least.
Very good. Can you hear me okay, Don?
I sure can. What's your topic tonight?
I'm just going to, if it's okay, can you see my screen? It's a Word document.
Not yet, but I see the thing is thinking about letting it.
Is it okay? I think what I wanted to do is just have a brief business conversation, if I could, and talk a little bit about my organization and then where we're at developmentally around the subject of analytics.
We've had people talk business stuff before. I think this would be great.
Yeah, so, essentially for us, I work in an organization where people really haven't heard of R. And things like Shiny and Hadoop are really foreign languages, basically, in the enterprise that I work for. So, in developing the organization and developing the capability, what it meant for us is that we had to make some big investments. And one of our early investments was not so much into, we do have R installed, and it's probably the loneliest server at our company. What we're really working to do is to get analysts into the business along with installing capability across the business, which would include things like TIBCO, Spotfire. So about a week ago, we made a pretty substantial investment in TIBCO and Spotfire. And are you able to see anything yet, Don, at all?
Not a thing. I'm going to make you the a participant. Oh, up there, it just came up. It just came up.
Okay. All right. So, as a organization that's really new in approaching analytics, so we've heard from a lot of different organizations that come in and tell us about sort of what they would ask us to really pursue in terms of models and those types of things. But the one thing that we really lack organizationally is any analytical capability internally. So what we wanted to do first is really get into the business. I wanted to do a live demonstration, but I just couldn't do it from my business machine, so I have to just do something very simple here. But what was important to us was really getting people familiar with the concept of analytics. And we really wanted to focus first on visualization because today we operate in 32 countries, and you can visualize all kinds of interesting stuff formatted in all types of different ways. So we went ahead and purchased some licenses at least to get into the countries and different analysts that we have there to really begin the process of standardizing visualization for us. So just this week and even as soon as today, because again, these licenses are very new, we started working with just people internally about talking about analytics and talking about the concept of visualization. And what I'm just displaying here in a very brief and simple way is just one thing that's important to us is the production of printing and writing paper, because it really drives our storage business. So, we were chatting with different groups today, and what we were attempting to first look at was just where is their large production of printing and writing paper. And so we started to just do different displays showing, okay, we can see the United States, China, and then Germany has a large influx of that volume. We then displayed very quickly for them how to format it differently so that they can see it in trees and different methods, and even heat maps. We then went to things like pie charts. And I know these are very basic concepts for this crowd, but when you're really developing a capability in an organization that's not been exposed to it, this is where you have to begin. So, another business question that developed today was really, and has erupted, has been around, okay, we have a very large selling organization. We have lots of people who've been here a very long time. But how does time relate to overall attainment? So we sat with the sales operations team today and presented to them, okay, let's very quickly get into Spotfire. It allows you to quickly load the data. We'll plot it out. It then allows you to fit a line. And then we'll look very briefly at different model statistics that come with it. Now, we didn't get into this, right? But we did share with them the fact that if you think in terms of attainment and you're thinking in terms of time, naturally you would want it to go up and to the right, meaning the longer that people have been here, the more proficient and more capable they are at reaching high levels of attainment. So this was fairly startling to a group that assumes that people that have been here for 20 years or have been in the company 20 years are our highest achievers, which that doesn't appear to be the case. So we reviewed that with them very quickly just to give them a sense of the capabilities of the tool. When you're building the capability and you're really trying to go fast, you have to hire people to help you. So I have a group that helps me, and they're based out of Budapest, Hungary. So what they did is they're also helping us with learning TIBCO Spotfire. But what they did is they did something for another customer that they have by tracking overall profit of each airline flight out of a system called Amadeus that runs throughout Europe. I wanted to demonstrate it today, but I couldn't get on the machine to do it. But it's pretty slick. It allows them to adjust a price manager within a business to make adjustments to price based on airline and frequency of travel. And then it'll allow some images to display to OpenStreet off to the right into a pane that then you can visualize and understand the overall margin of that particular flight. So I think I guess I'll just close, if I could, by just this is a big accomplishment for us. We've come a long way in just turning the corner to make investments in these types of things. So that's why I'm a little proud of the fact that we've got this available to a large number. I mean, we have 200 of these now, and we're going to work to get 200 people at least equipped to begin to be familiar with doing visualization and light forms of analysis. So that's Don. That's really all I wanted to share.
You know what? I'm glad that you did share that, Troy. I wanted to say one thing is that I like about this talk is it really sort of gives an overview. What your organization is experiencing, they're getting into analytics, is actually very common. There's a lot of other organizations that are you would think from a university perspective that everybody's really super advanced out there in the real world, but they're not. They're sometimes a decade or two behind, and they're just getting into it. And when you understand where the world is, when you get out there in that real world, it's just people like us appreciating that. It will help you tailor yourself at an interview, and maybe it's more important to be able to explain this analytics to let's say a CEO or something than it is to be able to amaze them with your knowledge of principal component analysis or something. But being able to put this in explainable terms can be very valuable to your career and also to getting customers and just pushing projects forward. So this, I think, really gave a nice view of that.
All right, I appreciate it. Thank you, Don.
So anyways, so does anybody have any questions for Troy? I'm guessing that that's a no. But, so I just want to say thanks to everybody who presented tonight. This was absolutely a lot of work went into this. Outstanding talks from beginning to end. Variety. I love the variety. I love some people went into depth. Some people just touched on, gave a good overview. This is just good stuff. And I recommend watching this again, looking at the videos, and then going back and looking at some of the show and tells from previous classes. There's some real good stuff out there. You'd be amazed at some of the things. So anyways, if everybody who talked tonight could send their presentations, I would very much appreciate it, but that's up to you. There may be confidential stuff, but anything you send would be very helpful. So anyways, what I'm going to do is I'm going to stop recording, but I'm going to stay on for people from my 411 class or 498. I'll answer just general questions if anybody has them.